Good morning, everyone. Myself, Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling Basic Electrical and Electronics Engineering, subject code W25C01 under the Regulation 2025. So, today we are going to learn about microprocessor and microcontroller, their architecture, application, and the important components of 8085 microprocessor. This 8085 microprocessor acts as a brain of a computer system. While the microcontroller is a compact system designed for a specific control application, understanding these concepts is essential in electrical and electronics. So the characteristics of microprocessor is it requires external RAM, ROM, and I/O chips. This microprocessor contains only the CPU, so memory and input-output devices must be connected externally. So it have a high computational capability. So it can perform complex calculations very quickly, and it's suitable for the advanced computing task. So and it's flexible for the system design. Designers can choose memory and peripherals according to the requirements. So it having the high power consumption since multiple external devices are connected, power usages are higher. So it's suitable for multitasking and a complex application can execute multiple processes efficiently. So for example, desktop computers, laptops, servers. So these are all the example for this. And the microprocessor versus microcontroller. What are the difference between the microprocessor and microcontroller? The microprocessor is a programmable CPU implemented on a single chip. So it exhibit the function of arithmetic operation, logical operation, control operations. The main limitation is depends on external memory and input-output devices. Whereas in microcontroller, it integrates CPU, memory, and peripheral on a single chip. So in the features of the microcontroller is compact, it's a low cost and low power consumption. So the application of the microcontroller is a washing machine, traffic signals, smart home devices. So these are the applications. So what is the comparison between the microprocessor and microcontroller means? In microprocessor, it requires the external memory, and the microcontroller has the memory built in, the inbuilt. So the microprocessor has a high power, microcontroller is a low power consumption, and microprocessor is used for general purpose. It's used for microcontroller is used for the specific purpose. Then the microprocessor is used in computers, and microcontroller is used in embedded systems. The application of a microprocessor is personal computers is used for daily computing tasks, used by engineers, designers, researchers, and high performance computing systems which have a supercomputers, scientific simulations, and artificial intelligence. So where they use here we are using the microprocessor in everyday life. So this is the block diagram. So observe the block diagram carefully. It shows how different components communicate with the processor. So the processor acts as the central unit of the central unit, and the exchanges information with memory and input-output devices. So first the input CPU first input, we are giving input to the CPU. Then CPU it's processing and it gives the output. So this is the block diagram of the microprocessor, and the architecture means the component which is the CPU, it processes instructions, and on-chip flash ROM it stores the program permanently, and on-chip RAM it stores temporary data during execution, and the input-output ports it connect to the sensors, switches, and displays. Timers and counters it measures time and count events. Serial interfaces, UART, that is serial communication between the devices. SPI means the high speed communication protocol. I2C means a communication using two wires. ADC and DAC also. ADC means converts analog to digital signal, and DAC means converts digital to analog signal. Example, the temperature signal, temperature sensor is converted into ADC, converted into microcontroller. So these are the architecture. Next one is the CPU, that's a central processing unit. So the CPU is called the brain of the computer, and in register it stores small storage locations and have a very high speed. And the ALU performs the arithmetic and logical operations, that is addition, subtraction, and or. comparison, and the control unit, it controls all the operation and it coordinates the data movement. And the caching memory is a fast memory near CPU and it improves speed. And then the input output means the receive data from input devices and sends results to the output devices. For example, the calculate input is number, CPU is the calculation, output is the result. So this is the one. The accumulator and ALU in 8085 is accumulator means 8-bit register used to store the intermediate results. The importance is most the arithmetic and logical operation occur to the accumulator. And the then ALU arithmetic. Thus, if 5 plus 3 is equals to 8, the result 8 is stored in the accumulator. And the arithmetic and logical unit of the functions perform arithmetic addition, subtraction, and or XOR. So it performs the actual calculations and logical operation. For example, 20 plus 10 is equals to 30. That is the ALU performs addition and stores in the accumulator. Then the general purpose register and program counter. The general purpose register, the register B, C, D, E, H, and L. It stores 8 bits. And the register pass B, C, D, E, H, L. It stores 16-bit data. So the temporary storage during the program execution is the purpose of the registers. And then the program counter is the 16-bit register and it stores address of the next instruction. So the importance is to ensure the instructions are executed sequentially. If the current instruction is at address of 2000H, after the execution, the program counter becomes 2001H. So these are the program counter and the general purpose of register. Then the stack pointer is it is also a 16-bit register that act like a stack. So the 16-bit register points to top of the stack memory and the push button it stores into the data into the stack and the pop means it retrieves the data from the stack. So the importance is it's used in the subroutines and the function calls. Next, the temporary register is the 8-bit internal register and it stores the intermediate value during the calculation and the programmers cannot access it directly. Then the flag register. There's a flag register is the 8-bit register containing the status flag. Mostly we are having a 5 set of flags, that is sign flag, zero flag, auxiliary carry flag, parity flag, and carry flag. Importance is that it helps the processor to make the decision. After subtraction, processor checks the flags to determine the next action. This is the flag register diagram. So the flag register acts like a report card for every operation. It tells the processor whether the result is zero, negative, generated a carry, and so on. So this is the report card for each operation. Next one is the sign flag. It's an MSB is equals to 1, that is negative number. MSB is equals to 0, positive number. So sign flag is 1. So then 0 flag set, when result is equal to 0, the 0 flag is set to be 1. When auxiliary carry flag is used in BCD arithmetic, when carry occurs from bit 3 to bit 4. And the parity flag is checks the number of ones. Even number of ones is a parity 1 and the odd number of ones is a parity 0. So contain 4 ones, the parity is ones. So next one is the carry flag. When carry is generated, the result exceeds 8 bits, the carry flag is 1. These are the importance of the microprocessor. And today we learned the difference between the microprocessor and microcontroller, their architecture, CPU components, 8085 registers, stack pointer, program counter, and the flag register. These concepts form the foundation of understanding of embedded system and processor-based designs. So we will see the next topic in the next classes. Thank you.